Okay, good.
Yep.
Okay. Hi, I'm Mike Sandman. I am with Cisco, and I wanted to present something. So I've got a list of features that we've got at Cisco that are not in open source yet. Some of which actually I didn't even realize until yesterday weren't in open source yet. So the features that I'm going to be presenting are first, probably the biggest one is edge geoblocking, which is kind of exactly what it sounds like. The next one is session tracking, which also is it's basically a way to keep track of individual clients without having to rely on IPs. Device groups, ATS maintenance mode, which I did talk about at the last summit, but I'll just run through it quickly again. And then path prefixes is the last one. And then questions, and I know like the question on all these, when will this be open sourced? There's kind of a blanket answer for all these, which is, so we are using traffic control 2.1. We are starting adoption of 2.2, but we're still on the Perl UI, and everything is still Perl. So a bunch of these features would be fine to open source, but we need to port them to the Go traffic ops before we can do that.
I think for the backup edge cache group one, we just had you guys submit the pull request on the Perl, and then we are gonna do the Go.
Okay, that is, I think
that's what we did with that feature. But we can discuss them.
We'll probably need to approach them one at a time because each one's probably going to require different levels of stuff. Yeah. And then, any other questions, just feel free to ask. I don't really have a super long presentation. So the problem that we're trying to solve with edge geoblocking is that the geoblocking decisions tend to, generally get made by the traffic router. The clients go into the traffic router, and then the traffic router gives you basically yes or no, and then forwards you a cache, and that's the last you hear of it. But there's no protection on the edge caches for clients who really shouldn't be accessing the content. So a savvy client could just, if they know the URL of an edge cache, they can just go to the edge cache and basically get around geoblocking entirely. And that's actually not the only issue. There's also a client could also set the XMM client IP. I think I've got that right.
Yep.
You could set that as an HTTP header, and the traffic router will think that's your IP address. So if you are, if you have US geoblocking turned on and you're coming from Canada, you just set that to a US IP address and you get right through. And finally, this is sort of a lesser issue, but for DNS delivery services, since the request gets forwarded usually by a local DNS or delegated, I guess, by a local DNS server, the DNS delivery services make the geoblocking decision based on the local DNS IP, not necessarily the client IP.
I wouldn't say that's a smaller issue.
Okay. We don't have a lot of DNS delivery services. So, and most of the, really? Okay. Yeah, because,
someone was using a Google resolver that had nodes in Belgium, and the delivery service was locked down to the US and minor outlying islands or whatever. So we were blocking them.
Wait, Google resolved it, right?
Exactly. That's the problem.
One of the IPs behind our bid is in Belgium.
Yeah, but you should never, if you're in the US, you should never go.
Should never go.
Yeah, Google's fallible too. I mean, YouTube.
yeah, I heard that.
Last night,
Yeah,
so
YouTube did break last
That actually happened?
night.
Yeah. Okay.
Really?
What was I doing? All right. So yeah, like I mean, most of the time for us, like for Shaw, like the DNS is like right next to the clients, so we don't usually see this that often. But yeah, I guess you could even set your DNS server to whatever and get around geoblocking that way if you know what you're doing. So the implementation, and this was worked on by I know Eric was heavily involved in the design. and Peter Ryder, who a lot of you probably know and have talked to, and Bruce Osler, who is relatively new working on our traffic control project, developed did all the ATS work, and Manu Pathak, who I don't know if y'all know him or not. He's been with the team since pretty much the beginning, but he worked on the traffic router code. And I bashed my face into it a little bit and broke it a couple times. So it uses a plugin that is already in open source called authproxy.so, but Peter and Bruce added a new mode to it that allows for edge geoblocking, which I have an example on the next slide, or a couple slides which I'll need to look at. Basically what it does is it adds a remap rule to the cache, an extra remap rule to the cache for a geoblocking delivery service, or it's not even really a delivery service, just like an extra remap rule. And the remap rule goes from, it remaps the, basically the traffic router IP to its, I should have started with this. So for edge geoblocking, all the geoblocking decisions are still made by the traffic router, and the edge makes a call out to the traffic router and then gets a basically yes or no back from it. So that extra remap rule remaps the traffic router traffic router FQDN to itself with a couple of extra options. The transactions get logged both. Since there is an extra remap rule, and since the transactions come through ATS, it logs the transactions in the ATS logs as well as the TR log. I think it's in the access log. If not, they're in the traffic router.log. And it uses a new traffic router API. This is what Manu worked on, along with port 3333. Wait, what's up?
That's funny that we're still using that one.
Yeah, we don't use it, I don't think, for anything else, but we used it for this.
You'll see 3s and 9s in the code. Every good 9s and 9s.
Yeah, so the traffic router API accepts so it calls out to the 3333, there's some kind of endpoint, and then it passes in the client IP address as well as the URL as query string parameters. And this API call makes a direct call to the route function with a geoblocking decision. Usually, the route function, as I understand it, does geoblocking, all sorts of geoblocking, and then picks a cache at the end. But effectively, it takes the result of the route function, and if it's any cache, anything positive, it returns a success. If not, it returns nope. So the benefits of this is that on the edge cache, you're using the client IP every time. You're not using the client IP header. You're not using a DNS IP. It's direct to the edge cache. You're always what you come in with is what gets evaluated. So obviously that's going to improve security. The slight drawback of this was it was harder to test than usual geoblockings. We ended up needing to do some stuff with loopback, set IPs on loopback addresses and make local requests in order to test this, because we needed IP addresses from all over the place. If you have access to IP addresses in different countries, you could do that. So this is just something if you were going to deploy it in production, it's a little more difficult to validate than standard geoblocking. It logs, so we ran into we used Splunk for logs, and we were a little concerned about the fact that if this were turned on, it would actually double the Splunk ingest, and because you'd be logging everything twice. And so you would incur twice the license cost for Splunk.
Well, does it do it per session or per transaction?
It does it per session.
Yeah.
So it's not really doubling it, but it's
It's on startup, and if you do speak people out, you hope that you are only doing it once.
yeah. So there's that, and I didn't I have that on this slide, but that's this.
Yeah.
Which basically the configuration, which I'll show in a minute, takes in a regexp along with the, no, I think that's it. It takes in the regexp and it evaluates basically anything that the first request that matches that regular expression will get sent up, and then all the subsequent requests that match the same pattern will not. But in addition to that, it only logs it only logs misses in the transaction log, and that's accomplished by using the logfilter.so plugin. And there's also the main reason that it's going through the main reason that it's going through ATS on another remap rule is that we don't want to flood the TR with these requests either. So it actually caches the requests for 60 seconds. The traffic router will send back a max age header, a cache control header of 60, max age equals 60. This is what the remap rules look like. So at the top is the remap rule for the actual delivery service. And you can see there's the auth proxy.so, and then there's parameters into it. And then there's this auth host equals some giant nonsense string .cdn domain. And then below that, you have another remap rule that maps that big nonsense string to itself. That big nonsense string is actually a load balance. It's like a virtual FQDN that resolves to all the traffic routers. So this way it load balances between them. And then there's just a couple of, so this was shipped pretty recently. There's a couple of next steps. We need to do more performance testing with it. We've done a bunch, and so far we were concerned initially about the traffic router getting overloaded or the cache getting overloaded by this, and so far everything looks fine, but we do have a couple more performance tests to run for this. There's a few issues. There's one issue still with DNS, getting this to work with DNS delivery services. And unfortunately, I don't know exactly what that issue is. I know that they're still working on fixing a bug there. So it works right now for HTTP fine, but for DNS delivery services, there's still a couple things to iron out.
Did you guys look into the what is it called? GeoID ACL plugin that ATS has?
I did not. I would need to ask Eric.
There's a little plugin that I think that is related.
Well, so yes, that might provide like a gate that you could control with MapSite, but the way that they're doing it, they also get the benefit from the regional geoblocking
Yeah.
stuff and
CZF.
all of the other.
We get CZF, we get anonymous IPs, we get literally everything that the traffic router does.
And importantly, they get always the exact same answer the traffic router would have given them. So there's not a chance that it's out of sync or that.
They did one more thing that it does.
Yeah.
Outside of the host header or the client IP headers and the DNS server thing, yes. There is a, I guess, slight chance that somebody would come in with an MMIP header, get through the traffic router, and then this would not like their actual IP.
Right.
But yeah, outside of that, you're right.
Them anyways.
Yeah.
That's the whole point.
Yeah.
But it's drastically more expensive to do that lookup. So you say you did performance testing, but if you specifically done any kind of DDoS testing, so my fear would be this like works normally on a normal request, but if somebody knows what to do, so for example, if I were wanting to take your CDN route, right, what I would do is I would go out and compromise some IoT thing and build an IoT botnet of coffee cups, right? some idiot's internet connected coffee cups, and then make 10 million requests all at once. And they don't have to be fast, they don't have to be big, they just have to have different IPs.
So my reply to that would be, what's to stop you from doing that 4 times on 4 different coffee cups and sending 40 million requests to a cache today?
Or just skipping the caches, because that's really inefficient, and hit the traffic routers directly and DOS them. Because
Well,
essentially it's
yeah.
the same exact thing, right? You're just fanning it out across the edges of that cache.
Yeah.
So it's not harder to DOS
DOS.
Yeah, if you're talking about DOSs, there's always more, like, unless this is orders of magnitude more, unless this is orders of magnitude slower, there's always I feel like there's just more clients you could use to DDoS me.
But how many clients, I mean, a client can throw out at once, and it sticks with the edge for several minutes, right?
Yeah.
So it seems like you would be getting a lot more requests.
Do you do this on every request or just the initial request?
It only does it on the initial request,
What do you mean
and
by initial request?
the usually this would be like a manifest request. So there's a regular expression, which mine is not configured very well. Mine is just dot star. But normally what you would do is you would configure some kind of path with like a regular expression, like a wildcard after it. And then it would say, basically, as long as the requests don't, like you would give it like a base URL of a channel. And then the first request on that base URL of a channel, usually the manifest, this would go for. And then everything else that matches that path, it would not.
So it's a combination of both source IP and path regex.
Yeah.
And
Is
it
it
just
possible to
remembers.
ask
And it
for-
holds on
And
to
it-
that info.
Yeah, I think so. I'll bring that back to Eric and Peter, but I think that's basically the idea.
Okay.
So you had a
My other question was, so fundamentally, it's also a rate limiter too, because it means that for basically you can't move ATS faster than those initial requests can be processed by TR. So if you have undergassed TR in some way,
It's only going to roughly double the cost of a TR.
only roughly double.
Yeah.
I mean,
but
what are a few
That's not-
TR between friends?
yeah, but it's not.
Yeah, that's not that bad.
Okay.
So what about the thundering herd? So if 1,000 requests from the same IP against somebody's trying to attack you, is it going to do 1,000 requests in the TR? Or is it
No, it would just do the one. If they come from the same IP, then it would. And I think even with the, I would need to look up for that bottom. Is that that's passing the query string back up? But I don't think it's caching
It's
the
possible.
query string. So
Because it's possible to have a different base base regex for this than is in your cache keys, which means ATS would normally, during a thundering herd, hold back after that first
I
request.
was gonna say, he's going to have the same. You're going to have the same thundering herd protection because you're effectively fronting your TR with ATS there.
yeah,
So you're going to have the same thundering herd protection you always have, which
Yeah.
is going to be considerably better than what TR has anyways.
and I am pretty sure that this remap rule will ignore the query string in the cache key. And so if 1,000 people come in for 1,000 different requests, it'll be cached for 60 seconds anyway. So you'll only get one request per 60 seconds per IP.
Considering that TR already has port 80 and 443 and 53 exposed, we don't typically expose quad 3 today to the outside world, but you don't actually have to do that for this to work.
No.
Because you're using it's coming from the edges.
You have to whitelist it in from the edges if your traffic routers are like on a different subnet. But no, you don't have to expose it to everyone.
Okay.
Any other questions for this? And like I will all these questions I will double check with the people who actually implemented this. So okay, session tracking. This one I actually wrote, so this one I might know a little bit. So how do you track down a specific client? Like we have we have customers asking us like we want to be able to track in the event of an issue a particular set-top box, and we don't have like at Shaw for example they do like Shaw has logs with the device IDs, like the X1 device IDs.
Yeah.
The CDN doesn't get those, so we can't use that if they.
Money trace isn't in there?
We don't have money trace turned on yet.
Okay.
But it is in there, and thank you for reminding me. But not everyone uses money trace, so yeah. So you can't really use IP address because if you've got multiple devices in one home, they're all going to have the same IP address. So we've done something in the past where you would use a combination of IP address and user agent, and this would generally differentiate between somebody watching on their set-top box, somebody watching on their iPad, somebody watching on a phone, which,
yeah, you're not in linear IP world yet.
Sorry?
Linear IP, because then you'll have 3 boxes in the house that all have fog 1.0.
Well, yeah, that's the thing. User agent strings, we've noticed they sometimes change. And sometimes they add new ones, and sometimes there's things we don't recognize. And even with this, your IP address isn't necessarily going to be like what we're seeing with the XG devices. It's not necessarily going to be the IP that you see on the box. It might, if you're going through a proxy or a NAT, it'll be some IP that you might not even know. So session tracking implementation. So it's using the TS Lua plugin, and there's a Lua script called sst.lua for simple session tracking or Sandman session tracking. If it's enabled, it sets the set cookie header on the response going back to the client. It accepts a couple of the bottom bullet there. It accepts a couple of query parameters. You can configure a set of query string parameters to consider in the generation of the cookie. If the parameters are configured, if you have any query string parameters configured and you've passed them in, those query string parameters with the values that you set will be what the cookie is. If not, you just get a random UUID. Additionally, if a cookie comes in, and this isn't really part of the plugin, this is just part of the logs.xml or the log.xml.config. It logs the cookie header as in the transaction logs along with some of the other, because you can log any HTTP header you get, so it just adds this to the log string. And any new request that comes in with query string parameters that match what's in the configuration for this will override the existing cookie and will reset a new one. Go. Okay. So here's what the remap rule looks like for when you have it configured. You tslua.so, first parameter is the script, and then a series of query parameters afterwards. And then the logs will look like this. So the top request is one without query string parameters, and you just get UUID colon that thing. And then the bottom request, you can see I passed in duck equals quack, fish equals gold, and the cookie reflects that. One thing to note is originally I wanted to do this as separate cookies, but the plugin, the ATS remap header, it would only overwrite one header at a time. So if I passed it in as different cookies, you would only get the first one. So that's why the format, it's OMD cookie is the key in the actual, that matches the HTTP spec, and then the value is another set of keys values. Any questions? One last thing. So the applications of this, obviously tracking users using these cookie strings, but the other application is for URL signing, and there's a way to, we have a way to embed in the cookie the URL signature so that it and the URL signature becomes part of the cookie, and then we have a URL signing plugin that validates it. I don't know the specifics on how that plugin works, but the session tracking, the sst.lua script contains code to do that.
There's an open source URI signer that does something exceedingly similar.
Okay. All right. Now, any questions on session tracking?
Do you have folks in browsers using this?
In browsers?
Web browsers.
Uh,
Or is it just enclosed containers?
it's just, sorry, I don't really understand. In browsers using, or containers?
Yeah, so are people streaming this video or whatnot?
Oh, yeah. So we don't actually have this turned on at Shaw. This is usually going to be This is usually going to be in closed containers. It's usually the query strings are provided by the back office
Okay.
and are part of the URLs that are part of like the what is it, the RDZ
Right.
for Comcast. So it would be something like that. You would have the query string parameters in. It would either be part of the URLs or the actual device would generate them.
Right. So,
Um,
so we've run into two challenges with using this cookie-based approach. And the first is that some of our enclosed containers use separate contexts for manifest requests and for other kinds of requests. And that was interesting. And that can be solved with updates to the containers. But the other one we've run into is third-party cookie blocking. More and more browsers have third-party cookie blocking
Okay.
turned on by default.
So yeah, okay. Now I understand. The thing with that is that's not going to break. That's not going. This doesn't affect streaming at all. This is literally just tracking, and it's for the user's benefit.
It only doesn't affect streaming if you're not using URI signing.
If you're not using URI citing, yeah. If you are, you're stuck. But
Yeah.
But the generic session tracking, if somebody is blocking the cookies, we're just not going to be able to help them if they have a problem.
Okay.
Or even actually, I mean, if they're sending the same query string parameters, we'd be logging that, and we could track that.
Okay.
Like if that UUID is like a device ID,
Yeah.
like an actual like device ID on the device, and they just send that in every request, then the first request doesn't come in with a cookie header, but the code sets it on the inbound request so that it ends up in the log the first time. Any other questions? Okay. So device groups. So device groups was written kind of a while ago, I think, by our Shanghai team. The problem is that delivery services are generally associated with caches, individual caches, not profiles or cache groups, even though on the Traffic Ops UI, you can check a box to associate an entire cache group's worth of caches or an entire profile worth of caches with a delivery service. So often we have users say they don't really want that because then when they add a new cache, they have to remember to add that cache to all the delivery services that it's part of. If you have a lot of delivery service, that gets tedious. The other way to go about it is you could, when you add a new cache, you're generally going to add it next to, in a cache group, maybe with another cache, and you can clone the assignments from that. But, what if you're not? So the way that this was implemented is that there's a device groups page on Traffic Ops, and you can associate caches, you can have them be part of a device groups. And entire device groups can be associated with delivery services instead of caches. So when you do this, then if you add a new cache, you just add it to the device group, and then it's part of all the delivery services that device group is part of. Now, the other thing is that device groups can contain both edges and mid caches. And mid caches that are in the device group associated with the delivery service override the parent hierarchy for that delivery service only. So if you have like mid caches in Denver and edge caches in Boulder, I don't know, and then you have one delivery service where you want the Boulder edge caches to actually go to a mid cache in San Jose, you can do that by having them be part of a device group and then associating it with that delivery service. We have had requests where customers actually want to split their traffic by delivery service across caches within a mid group. I don't remember the exact reason, but they use device groups to accomplish this. All right, any questions on this?
Yeah, so to start with, I think this is great. So this is something that we absolutely have to have for self-service.
Okay.
So for self-service in the long term, if some random tenant wants to build a delivery service, we obviously have to have some system to automatically assign edge to that. Now, I guess my big question is, I thought on the self-service project had really just been to do a really simple solution and essentially just have some kind of default assignable flag on every server. So the server table would just have some new column and it would be something like default assignable, and that would determine whether any new delivery service automatically was assigned to that server. So
Okay.
So my big question is, I guess, have you seen the need for this additional? Obviously, this is much more powerful. Right?
Yeah.
You're seeing the need for all of this flexibility to have certain groups and certain ones on.
I actually cannot get into details with that, but yeah, we have seen a need for it. Specifically, that thing about the mid caches. But yeah, what you're like, and admittedly, this is one I'm not super familiar with, but for edge caches, something like that would work. We don't really, I haven't really seen a need for it for edge caches. Really for edge caches, it's literally just, I don't want to go click on 900 checkboxes for 900 different delivery services. But for the mid caches, it's necessary. We need it.
And again, for self-service, it's just inevitable.
Yeah.
So this is great. I think we should definitely keep this in mind with self-service and how they're going to work together. I don't see any immediate issues, but it's definitely something that will enable self-service. And then I assume most CDN deployers who just have CDN and a bunch of tenants will simply configure that on the CDN side, on the cache side, and these are the caches, and then they'll set whatever groups they need to automatically assign them to yes.
Okay.
So yeah, that sounds great.
All right. Thanks.
So where do you see the touch points or overlaps between device groups and flexible cache groups?
Yeah,
Um,
I was thinking about that as well, but we are also talking about, bring your own topology and sort of make things not as static as they are now. And we need to figure out how to, this is probably a good middle ground. Right?
Yeah.
This is probably, because you don't want for every delivery service to be defining this is my topology. 9 out of 10 times you're going to be saying, I want it to be kind of like this, or kind of like that.
Or
So
again,
I think this is a good middle ground that we need to see if we can implement that.
I
Today,
think we need that. We need a way for a CDN operator to be able to say, someone else, some other tenant can make it yes, and we can work on that.
I mean, today, if you need to partition your gear, you do it by separating out into separate CDNs. I mean, that's the hard wall. And internally, there are no real soft walls because it's shared pool of physical and network resources beyond that point.
unless you don't have like fallback edge groups configured. Or like if you have, I mean, we have situations where you have the geo-blocking policy is set to CZF only.
Right.
And then if you've got 2 edge caches and you lose the data center, you get 503 for everyone in that region. So if you have, so I mean that we see that as a hard wall.
Okay. Yeah.
Uh,
I hadn't thought about the routing implementation variances that can cause that.
I will say, I definitely think as a TC project, we need to get better about our documentation for all of these things, for cache groups, for device groups, if that's a new thing, for flexible cache groups. Because currently, you go to read our docs, and it essentially sounds like, well, a cache group is, right now a cache group is a collection of geographically located cache groups, but we're talking about radically changing that. And it's so easy for us to just document this is how it works without ever having a page that says, this is the idea of what a cache group is, what a flexible cache group is, what a device group is. I think we need to get better about those routes. Just to make it easier for a new person trying to deploy TC to understand what these things are.
yeah, that's a good point. Anything else for this one? The last 2 are short. Okay. All right, so this one I kind of did at the last summit, but I'm just going to run through it real quick here. So one issue that operations people have is that the clients will sometimes stick to the edge caches, and when you do maintenance on the edge cache, you bring the cache down and the client freezes, and then you have to retune, the customer will have to retune in order to go back to the traffic router to get sent to a new cache. So we have a script, Eric wrote it, ats maint.py, that temporarily rewrites the remap.config on a cache so here I've got that same remap from the last example, from the session tracking example. And then that's what it normally looks like. That's what it looked like before. And then you run the script, and then it ends up looking like the bottom line, where you have a redirect temporary back to the traffic router for that delivery service. And then to bring it back, you can run the script in restore mode. The script copies off the existing remap file into like a backup, remap.config.back or something. And then the restore mode will put the .back where it was. Or you can just queue updates, and then your remap gets overwritten anyway.
Clients are happily following that.
Yeah, usually. So caveats. The first thing is that if you do this like during prime time, or if you do this during if you have like 10,000 connections on your edge cache when you run this, everyone's going to get sent to the traffic router at the same time.
Yeah.
So that's not good. And then the other one is that there's an order dependency where you absolutely must admin down the cache in traffic ops, and it must be noticeably admin down by the traffic router before you do this, or it'll just 302, and because of consistent hashing, the traffic router will just 302 you right back to the same cache, which will 302 you back to the traffic router, and
Loops are fun.
yeah. So some ideas for this and some things that I mentioned last time is that right now we just have it as a script that runs on our salt master. We have like a salt command that does salt state.apply this. But it would be better off in traffic ops or traffic portal. So this way you could handle this order dependency. Like you could admin down the cache or set it to drain state or something. And then when you queue updates on it, because right now edge caches don't really know that they're offline. So this would introduce some kind of state on the edge caches, but you could just have this be part of being admin down, and then the cache will automatically redirect.
So how does this work for DNS delivery services?
I don't think it does.
Problem clients.
Yeah.
HTTP long-lived streaming sessions are the problem that we're solving for here.
Yeah.
Oh, wait a minute.
We do have clients that use DNS for long-lived sessions, and they'll get a 302, they're going to traffic router, and actually if they follow that, they'll just get redirected to the other side.
So for DNS delivery services,
The traffic router will be like, I don't know.
wait,
Right. Yeah.
I know this one.
It's
For
just
DNS
it's gonna drop out of the answer.
For DNS delivery services, the clients actually get back a list of A records.
Right.
It's not just one cache. So the client could, in theory, just move on to the next one.
Or eventually it will make another DNS request, depending on the stub resolver on the host, because the 30 seconds TTL on the DNS delivery service will expire.
Yeah.
My question is somewhat similar, but different, is do you do this on object type, or do you do this for any request? So if you turn an edge cache to admin down and flip it in maintenance mode, and video fragment request comes in and you 302 them back to traffic router, you're going to pollute the crap out of that cache memory, because that one asset is now spread everywhere, because with linear, or with IP video anyway, we use the initial manifest request for a VOD asset, for example, to dictate which specific cache you ask for. You do that in the middle of the stream session, who knows where the hell you're going to go. I think if you put a filter on that and said only do this for manifest, that would work for linear, but for VOD, you get that manifest once.
Yeah, once.
And even if you do that, well, okay, yeah, because that's what I was thinking was for VOD, you're still gonna brick the clients if you do that.
Right. Well,
For linear, yeah, you request it every couple seconds, so.
Yeah, so we've, but it is also different. The manifest is potentially different. I don't know if the URL is always the same, or if that is also incrementing. I don't know that, but.
So the only question I would have then, and this might be my lack of understanding of consistent hashing, would be how would that be any different from if you admin down the cache and somebody requests because
we drain it. We let that session in, and eventually we pull the rug out. The linear guys go back to traffic router to restart their CNN session or whatever it is, but the VOD guys eventually drain out. If you kept track of that initial request, you could save off that first URL that first came into
Yeah.
the edge cache, and then keep that reference until that client either goes away or you go into maintenance mode. Then if you go into maintenance mode, then you 302 them based on, you may have to do your traffic router trick that you were doing
Right.
For the other use case.
Yeah.
Get the 302 from traffic router and then serve that, which is actually going to be a 302 to a different cache. You would 302 them from this cache to the next cache
Yeah.
rather than sending them back to traffic router.
Right. So so just making sure I understand the issue is that effectively the hash key that the traffic router uses to determine which cache to send it to is the manifest URL. And if we use a different URL, it'll
Because you could be, different players are going to be at different points, and so you'll be on fragment 4 versus 132, and so those will go to different hosts and you're going to pollute.
yeah.
You'll pollute efficiently though.
The only thing is like,
go to the same spot.
so if the VOD dies in the middle, if let's say we don't have this and the VOD, how am I on time, by the way? I think I'm okay. If the VOD dies in the middle of the stream, if we don't have this and I admin down a cache while a dude is watching TV, and then he has to end up reloading the VOD.
Yeah.
Then he'll go to a different cache anyway because the one that he normally would go to is down.
Right.
How is that different from your case with using the TS?
Because if the TS is the URL that the traffic router sees, then it's going to consistent hash on that, and that URL will not be consistent for the whole population of clients playing on that one asset.
Oh, right, because everyone's in a different point of the stream. Okay.
Right.
Yeah, all right. Yeah, I didn't consider that, so that's a really good
And
point.
also, though, if you're not using persistent connections from that client, you've got no ability to maintain that state. Not no ability. You could do something clever with, based on client IP, but who knows if that's ever going to go away. So if they make a request to the edge for manifest, then sever the HTTP connection, then make a request for a fragment. Now you don't have those two requests connected together because
Yeah.
you've broken that
Didn't
connection
you,
from those HTTP connections.
Didn't somebody yesterday mention that we wanted to have a traffic router have a regular expression that it routes on and not just all paths?
Yes, actually, that's a very good point.
And if we do that, then we solve this and
Yeah.
everybody's happy.
So what we're putting in the traffic router is for actually it's the exact same use case.
Yeah.
It's just a completely different use case. But it is really the exact same use case. So if you've got a path that has like a zip code in the middle of it, and that zip code in Denver could be any number of zip codes, you still want to hash all those guys to the same thing. So we're putting in a feature to say, based off of a regex, hash on this part of the URL and ignore other parts of the URL.
Oh, okay.
So what we could do with this use case is for this delivery service, you could basically just say, use a regex that only considers up to the
Basic.
slash.
Yeah.
And the
Kind of like for
file,
geoblocking,
chop
kind of
it.
like the regex for geoblocking, where it just says this part is going to be, this part's going to vary, this part will be the same, this part will vary.
Correct.
Yeah, okay.
But
Yeah.
that'll-
Actually, we should maybe look into that feature a little bit more, because that might give us more bang for our buck if we can build on top of that.
Yeah. I mean, I don't actually use this, I don't use this at Shaw yet. Like, we just have it. And to your question about the clients, most of the clients, like pretty much all the clients I've tested with, like it works for curl, it works for the Shaw client that we have in our lab, but we haven't done any real tests with actual clients yet. So I haven't rolled this out yet.
The thing about all these things is that we're kind of making the CDN clever. The clever CDNs are CDNs that have problems as well, you know what I mean? They go
Yeah.
down and they do things that you don't expect. It's
Yeah.
always better because we're good at dumb.
Yeah,
Keep it simple.
bunch of proxies.
Yeah.
Yeah.
That's the one thing, you're kind of teaching the CDN about video and structured
Right.
URL and all that other stuff. And
But
it kind of makes my toes go like this a little bit.
Yeah.
But it is necessary sometimes.
All right. And
Broad classifications of traffic patterns are not the worst.
Yeah, maybe.
if you're just matching on URL, a URL is pretty generic. Like if you start giving it like M3U8 in some of the patterns, then we're teaching it about video. But if it's just the front of a URL, it could be just a directory, which actually leads into path prefixes, I guess. So this I didn't realize wasn't an open source, so I threw it on here. If you want to have the same FQDN point to two different origins, we had a use case. Actually, we have a use case for this at Shaw. Shaw is thinking of migrating some traffic over to the traffic control CDN from their legacy CDN, and they need their clients use the same FQDN for both. I think it's for speed tests as well as content. And so we ended up doing this with path prefixes. So the path prefix accompanies a host regex, and you essentially give it a root directory, and the remap rule matches on the FQDN plus the path. And the path that you give it ends up being removed from the request that goes upstream. So it'll map.
Isn't that just a regex remap, really?
The path regex?
Well, yeah.
So yeah.
That being a regex remap?
There's a reason you can't use that. And Eric sent that to me this morning. I'll need to look that up because I don't remember it, but it's something to do with regex remap. Yeah, you could probably do this with regex remap.
I think so.
Wait. No, would traffic ops complain that you have the same host regex twice? If you do that? Because I know that if you try to use the same, try to use the same host regex in two different delivery services, traffic ops will usually tell you no. So if you have a regex remap rule in addition to the host,
There's something there. I don't know.
yeah, and this gets you around that. Any other questions on this one?
So you put this in the regex table as a type path prefix?
I think so.
Basically,
No, actually, I don't think so. This isn't, the implementation of this is not in the same drop downs as the regexes, it's actually underneath it. So it may go into the regex table along with the host regex. Internally, I don't know. Yeah, this was, I didn't write this one either.
Because we were talking about maybe getting rid of this regex thing and making it simpler, but we need to make sure that we don't stop all of it.
Well, you could still do that, and then for the example of for Voluspa, for example, you could have your thing at the top be just what these remap rules are, and then you could either remove the path or you could not remove the path and use a regex remap to remove the path.
so path prefixes is kind of an S3 concept. They use it for S3 bucket routing, and have since abandoned it as an idea because it caused other problems. So if I'm fronting just generic website in front of or behind the CDN, right? I have to encode URLs into links, references, all that jazz, which means that the concept of a path prefix like this just fundamentally break relative pathing in URIs, or force you to pin content to particular origins, which kind of defeats the purpose somewhat of how CDNs protect origins?
Maybe.
I mean, yeah, it'll probably get shuffled out on the back end, but if I'm doing something with relative paths,
I think you're still okay. I think the relative path should be relative to the origin 1, origin 2.
but if I do a curl and I say in its relative path to, like, say /API/ping, right? That's not going to magically work if I say /origin1/API/pain, or rather it might, but anything that references
Yeah,
that will, yeah.
I would need to think about that. Like I think for I think for HLS clients, I think you're okay, but I think for if you're using curl or
Is there a way you can do it actually for say?
Well, that's not what
No,
we're
that's-
trying to accomplish here, right?
yeah.
It's the same thing that S3 does with bucket routing, where you can say, go to this bucket and look for your stuff here, versus go to that bucket and go look there.
Yeah, it was my understanding. I mean, I know that for for HLS video, the relative path is usually relative to the last thing that it requested.
Okay.
So that works. But for other uses of relative paths, yeah, that might be an issue.
Okay.
That's the with the like at ACL and that, just make sure you're not doing the margin you don't want to go to.
Path ACL. Well, you would the remap. I think the remap config kind of does that for you. Like, if you just requested Vegeta Edge Live CDN DBZ, then it would throw a 404 not found on accelerator. So it would literally have to match the name and the path.
If you do a regex, then you have to do that, because you can end up, you're tagging it to a domain into a regular expression. If you do dot star, it can create anything that's in there. Like,
Your index would have a list of
yeah,
sorry.
yeah, we've done all this for all kinds of
See the
projects.
previous CDN using that.
All right, I got like 4 minutes of battery left. Any other questions? All right, cool. The end. Thank you.